Hi everyone and welcome back to another video of CS202 Online. If you're watching last video, I needed to take a quick break, ate a banana, feeling much better now. So we're gonna finish talking about these topics and complete everything that you need to know for the first exam actually. So the last video before the exam. So last video we were just talking about allocating dynamically two-dimensional and three-dimensional arrays. And we did that. I finished it off, and now I just wanted to talk about these last two things in there. It's particularly the shallow versus deep copy. So let's go back into the code. We're just doing this code. We tested it. It runs. No memory leaks. Everything is fine. But I want to point something out. So let's go to the top of the code. Actually, let's go to the bottom of the code. I want you to remember that what happens when you try to assign one array to another array. Okay, so if I go in here and I make two arrays, I'm going to call them x and y. So we're going to do x gets 10 and make it the same size. Y gets 10, and I say I want x and x. I want to copy the contents of x or the contents of y into x. If I try to do this and I try to compile it, I want to see, I want to remind you what happens then. I get an error, and the error says invalid array assignment. What this tells me is that you cannot assign one array to the other one. You can't copy an array into another array, right? So how do I get around this in 135 days? I just put a loop and copy the contents over, right? Like a little for loop that says for int I equal to 0, I is less than 10, I plus plus, and then I start copying. I'll do like x I equals yi, and so I just do what's known as a member-wise copy, and that's how you copy arrays. And you still gotta do that actually with dynamically allocated arrays. However, there's an additional sort of warning that I want to tell you about that. We have our three-dimensional array that we did, right? It's up here. It's all good. We made it and everything. So what if we make another one of them? So I'm just gonna copy and paste the whole allocation part, and I'm gonna call this AR3D copy. Okay. Everything else is going to stay the same, the dimensions and everything. I just got to update the lines to say copy there, copy there. And this allocates the array. I'm also going to copy the deallocation section too. By the way, to simplify this, I don't need these brackets here. Yep. I do need them for this one though, because I had to have two lines. But yeah, so this I can bring up here like that. And the reason why is just because I want to keep this code base small. And this is for copy array. So AR3D copy, copy, copy. You probably could do this faster with keyboard shortcuts, but whatever. Okay. Yeah. All right. So before I do any copying, let's just run this in Valgrind and make sure I didn't add memory leaks or break anything. So no memory leaks. Okay. All good. All right. So let's try to do the copy then. Obviously, I want to do the copy before I do the allocation, but after I do the allocation. So somewhere in here. So I could actually write the following line of code. AR3D copy gets AR3D. Now I'm going to bring my cout array. So this is my print. In fact, I should probably write this as a function. Yeah, I do have just some links on there so you can practice using pointers and functions, which you definitely should. If not, you'll do in the assignments. But the same rules apply as any other parameter. Just put asterisks in as well. So maybe we'll do that a little bit. Maybe. In fact, yeah. Well, maybe we'll see. I don't want to make this longer than it has to be right now. So, I'm just going to actually, yeah. Just put copy here, and yeah, that's all I gotta do. So now I think if I run it, I have all I have is segfault. What happens? Oh, yeah, well, yeah. I know I have a segfault. I know why actually. Actually, I don't want to say I know why, but yeah. So right now, I have one of the arrays, and then I have the other array, which you can see has random garbage in it. Finally, we get some random garbage with dynamic allocation. I know last video we kept getting zeros. Proof that you don't always get zeros, because now you're not getting them. You're getting some interesting numbers, but yeah. So you got the second array's got some garbage in it, right? And so, very cool. Okay, so I'm going to go ahead and then try to copy things this way, okay? So I'm going to try to just copy it that way. So I'm like, yeah, let's just see if that works. Copying one array into another one. Does it compile? Yes, it compiles. Does it run? Well, in this case, you are going to get a segfault, but it's not for the reason you think you are. So it's segfaults. And if you want to see where, we can run it with a debugger here. You saw like a line right here. It's segfaulting. Actually, that's not where I thought it was segfault, to be honest with you. I thought it was going to segfault in the deallocation. Oh, we did the deallocation already here. That's probably really bad, actually. Hold on a second. Wait. Let's move the deallocation of this after the copying, right? Because otherwise we're doing some dangling pointer, like, oh, just nastiness. In fact, let's just put it here. In fact, actually, for now, to prove a point, let's comment out all the deallocation. Now it shouldn't segfault. It doesn't. And you can see that it actually looks like the copy worked. 822.699.336, and the next ones are 822.699.336. You're like, oh, okay, very cool. I can't do this with normal arrays, but I can do this with pointer arrays. Like, I can just copy arrays over, and it works really cool. I mean, you did a form of a copy, yes, but, let's bring back the deallocation. Let's see if this crashes, or if it just runs with errors. No, it crashes. You can see the copying works, but then it segfaults. Why does it segfault? Well, let me show you Valgrind. I'll put on this. Valgrind's going to tell us probably why. And then you actually understand what is really happening here. So Valgrind says 70 errors from 9 contacts. Okay, you're like, oh god, don't freak out. By the way, if Valgrind gives you like this many errors, it could still just be like one line of code that's wrong. It's just that the same line is running in a loop because it's a 3D array. So no fear. Don't freak out. But if you go to the top of the errors here, invalid read of size 8 at line 60. So the error is happening right here. What is happening? Okay. Address is 0 bytes. Remember last video. This means that this was already deallocated. Okay. And it was deallocated by line 56. You're like, so this was already allocated by this line. You're like, huh? The copy was deallocated by the pointer to the main array? Well, yes. And when was the main array allocated? At line 9. Yeah, it's the beginning. And you can see that the other ones will give it the same error repeatedly again, for the most part. So here's what's happening. This is what's known as a shallow copy. Okay? So go back to our really cool picture, and let's take that picture and copy it so I can, draw on it without modifying our original art. So what is happening here is really interesting, actually. If you don't mind me if I say that. So this is our AR3D, and our copy is technically the same thing because we allocated it. So this is our copy. Okay, in fact, here, let me actually shrink this enough that I can put them side by side. All right, so we got our copies, right? So this is AR3D, and then this is AR3D. Let's put the copy on this side, okay? So when I do the following line, AR3D copy gets AR3D, which that is the way I did it, right? I didn't do it backwards. Yeah, I did do it right. Okay. What is happening is you're telling the computer, take the AR3D pointer and assign that address, because the pointer is an address. So take that address and put in that pointer value the address of whatever AR3D is pointing to. So what I'm doing is AR3D here is literally just this right there. That's what that is. I'm saying, yo, take that and copy that value over into AR3D copy. So now, rather than pointing to the first entry there, I'm pointing here. Let me highlight it so you can see it better. Okay, that is what is happening there. That's what I'm doing when I'm saying that line of code. I'm literally cutting the link off to the green one here. So I'm losing this, and I'm just making a point there. This is what's known as a shallow copy. In fact, not only is this a shallow copy, but like I also have a massive memory leak now, because like I actually just lost access to all of this, because my only access to all of this was literally here. Like I need that. Like this, like step 1 to step 2 is like super important, because I lose access to the rest of the map. So of course this works. Like in terms of C outing, I'm like, I see a duplicate, because all I'm doing is like I'm looking at not like an alias of the other pointer. So of course I can access, I can even modify it. But to show you that that's really what's happening, let me modify a member of the array after I do the copy. So let's take AR3D and modify the first entry of it and put a 42 on it. All right, that's going to be a bigger number, so it's going to make it look on the line, but it's 42, so further meme. Let's do that, and let's see if it's really a shallow copy. Then it's not only going to modify the original array when you print it, but it's also going to modify the new array when you print it. Okay, just to make sure that I am printing the before and after, let's go ahead and where's my printing? Here. So this is the one that prints the array. I'm going to take this. I really should be functionizing this and put it right after. So it's going to print both arrays back to back. Okay. Hold on. Run it again. Okay. Sure. So right there is the original array. I had 921 in the beginning. And now here's a new array after I modify 42. That happens after the assignment. And then I'm going to print out the copy array, which is right beneath it here. And you can see that that has been modified too. So now both of them have 42 on them. So let's undo that. Just so I don't have that massive amounts of code. So that shows me that all AR3D copy is now is just a pointer to the old array, but it's not a real copy of it, because they're referencing the same thing. So you change one and the other one changes per se. Not good. Unless that's what you're trying to do, probably not good. And more than likely that's not what you're trying to do. You actually want to duplicate it. So you're gonna have two original copies that are independent of each other. Okay, so what do? Just do it like you've been doing it in 135. Use a for loop and copy everything over. Call it a day. So how do you do that on this here? Well, label the shallow copy and just go ahead and do a for loop. So let's go ahead and take this for loop here. And then in here, We don't need any of these brackets. Simply say AR 3D copy, and then the indices I, J, and K gets the original AR 3D. I, J, and K. That's a deep copy. Okay? And also, by the way, I don't know, I think I've already mentioned it, but like the reason why that's crashing is because not only do you have a memory leak, but then you're trying to deallocate the same array twice, because remember, AR 3D copy was pointing to the same array as the other one, so it's crashing for that. You're double deallocating stuff, which is why when the error says that this thing here has already been deleted by this, because yes, you already deleted the old array. So when you're trying to delete the new array, which is just literally the old array, it's trying to delete it twice. So that's where that is coming from. But now I am not doing that. I am doing a deep copy, which is a member-wise copy. A member-wise copy. Okay? Now, even if I modify one of the arrays, the other one will remain the same. I actually did need to have the cout back in there so you can see that. So I'm gonna have to copy that again. Very cool. So I'm gonna put it right here. Okay. So if I run this, this is my original array, 667. Okay. And then, what do I have? I do the copy, and then I change 42, and then I'm going to print them out now. Oh, crap, I copied the wrong, I copied a little bit too far. I copied this rand stuff. We don't need the rand stuff in there. Okay, so I just need the printing. Really should make this all into functions. So maybe I just do that. Maybe, nah. Okay, so we got the original array, 797 at the top. Now we do the deep copy, and then I modify just one spot in the original array, which you can see here, 42, but everything else is the same because it's still the original array. But the new array, the copied array, still has the 7 there. So they're no longer are they connected, and it's its own thing. And of course, there is no sec fault and no memory leaks now. See that? All heap blocks were freed. Here you can see it better actually. So this is the original array. This is the original array with the 42 on top, but you can see that this one is still what it was before, 013, which is shown here. Okay? So that's a deep copy. It's just like you would do it with the normal array back in 135. But it's important to point out that you have to be careful, because whereas you get an actual error with a normal array, static array, you don't get an error with a dynamic array. It just works because you're just changing a pointer. But you're not really doing what you're thinking you're doing, which is actually copying it over. So it can lead into problems later on down the line when you're deallocating or when you're modifying in one and the other one changes too. So not good, not good. Okay. So what I think you should do to this code on your own time as good practice before the exam is actually convert this code into functions. Make a function that actually prints out the array. Make another function that is supposed to copy the array over, like a duplication function. And then make a function that randomly fills the array. And functionalize this code. Maybe even make it into a class. Perfect review for the test. Highly encouraged. Not going to do it right now because it's not really a point. It's a whole 135 review. So I'd rather talk to you about classes for a little bit. So for classes, what I want to point out is just an example of a constructor. So let's just make a simple class that contains a pointer in it. Okay. So if I go and say int p for p pointer, and I have a normal variable too, just so you can see the difference. In my constructor, what I typically will do is I would initialize normal variables, right? Well, it's the perfect place also to dynamically allocate any dynamic variables you might have. So you could do something like p new int here, and then initialize it to whatever you want it to be initialized to. So maybe p gets, maybe there's a parameter here. It's default parameter of 0, so you just get whatever I gets passed in. Okay, so that's literally what is beautiful at constructors, is they run when the object goes into scope, like when it first gets made. So that's the perfect spot to start doing dynamic allocation. Same thing for an array. If there's an array in here, then you just do the same thing. Try it with the 3D array. Make a 3D array right here. You just put extra asterisk here, and then just dump all that massive for loop code to dynamically allocate it there. But now more importantly is the destructor. So the destructor runs when the object goes out of scope, right? It's the last thing that happens before the object is ever like seen. It just goes. Before, you really didn't have anything to do here other than say like, hey, this object is gone. But now, guess what? If this object is gone because it's going to go out of scope, it means it's never going to be used again. That's the perfect spot to clean up any memory that it's still holding onto so that it deallocates nicely. Because otherwise, it's not going to deallocate. Remember, the only time that memory gets returned to the operating system is when you either deallocate it manually or your program terminates as a whole. Not when an object goes out of scope or this class ends per se. No, it's when the entire program terminates. So this is the perfect place to do something like delete P. And so now it gets deallocated whenever you need to. So like if on main I go and say AA or another A2 here, A1 and A2, when the object gets made, it gets allocated, and then when it finishes, it gets deallocated, and that can happen. In main, I mean, it kind of feels a little pointless because that's the end of the program. The function ends, the program ends. But if this was probably like a random function, like a foo function, then it would only happen during that function. That it would create it and destroy it. So like, if I go and say like that, I forget that's how I'm going. Then I can just like do something like this. And if I run this through the debugger, foo gets called, goes to A, the constructor of A, dynamically allocates P, assigns the value of I, which is 0. Then the code happens. In fact, here, let's just add some code here. 2 plus 3. I don't know. Blah. Okay, so the constructor is going to run. The object is made. Then you're running the code in the function. And when the function ends, then it goes to the destructor, deallocates that so you have no memory leaks, and then the function fully ends. Now we're creating this object. Object gets made. Function ends because this is the main ends, goes to the destructor, runs that, and then end of that, and the function and the program, you're good to go. Run this to Valgrind. No memory leaks. Okay, so destructors are great for that, the allocation. Only issue is you gotta be careful is if you're doing things like shallow copy. You gotta make sure that you don't double delete stuff and that kind of thing. Okay, so just last thing, let me show you one with array, because why not? So if it's an array, it'll be like unit 4, I don't know, or it could be a parameter. And then here you would say delete R. Okay, that's all there's to it. So this is not the end of talking about pointers by any means. In fact, we're going to talk about virtuals in the next sets of videos, which is kind of expanding on the usage of pointers, and things are going to get pretty cool actually from here. It's more my interest. I really do enjoy that section of the course. So this is more of an introduction to like pointers, using pointers in classes and things like that. But by no means is this the end of this. There's so much more to do and learn. So I welcome you to kind of look that up on your own time and check the additional references I have. But we will cover a lot of things in class though. We won't cover everything there is to know about the pointers and dynamic memory allocation, but we'll cover a lot of it. Okay, so that's it. Yeah, this is a short video because this was kind of like the appendum for the last video. So With this, you are now a dynamic memory allocation expert. You can make pointers all you want and dynamic, and everything's gonna run awesomely forever, right? Hopefully. But like I said, just as long as you're careful with stuff and you know how to use the right tools to fix problems that you do run into, like Valgrind and your debuggers and reading compilation errors, then you don't have to fear if things don't work out the first time, because you know how to fix them easily. In fact, you just part of life. You just embrace it. Like, oh yeah, I get an error. Okay, fix. Oh, I know how to fix it. Done. Moving on. That's how you want to, the attitude you want to have. So you don't want to be afraid of errors. They're just part of things you do. But still, you want to be careful, code good to avoid as many as you can, so that you don't spend a lot of time fixing errors or code works the first time, which doesn't always happen, but it is nice, definitely. We all get it once in a while, right? Well, if you're coding Python, it always just works, and you're like, whoa, why? You're like, okay, I won't question it. It's just Python. But we are in C++, so it's more of we're going to get some errors and then we're going to fix them. So with that said, thank you all for watching and your patience and splitting this into videos. It's been a long session of classes right now, the recordings, but it's a lot of content to cover, and I really wanted to make sure you get all the important key materials. So thank you all for watching, and I'll see you all next video. Take care.